Hello, this is lesson 14 of P2 topic 1 forces. I had to think for a minute there. And it's on moments, and luckily it's something you've done before in year 9. So if you were a pirate and you got your pirate boat, and one of your favourite things to do is make people walk the plank. Okay, so here we've got a plank. As the person who's walking the plank, and obviously we're going to have some sharks in there. As a person's walking the plank, the moment on the piece of wood is going to get greater. So what do we mean by moment? Well, moment, sometimes known as a turning moment, is a value that is created when a force, in this case it's the weight of the person, the force is acting a distance, and in this case it's how far away from the ship, so distance from the pivot where it's hinged, so in this case where it touches the boat. So as they move across, the moment gets larger, and we see the equation for that. It's very easy. It's just force in newtons times distance in meters. And the unit for moments is Newton meter. Okay, so from year 9 hopefully this might start ringing a bell. And it's why in the old days teachers used to have an awful punishment. They would take a wall, they would get a naughty child, none of you guys of course, and they would make them stand against the wall, so not very happy, and make them put their hand out, and they would put a book on their hand. And you think, ooh, a book, that's not very heavy. Little force. But because your hands were out like that, actually the turning moment got quite big and it became very uncomfortable. Not that for a second anyone would do that nowadays. It's why when you're picking things up, you pull it close to your body. You wouldn't dream of trying to lift a chair with your arms outstretched wide. So that's moments. We're going to get pink. Where is it? Pink. We're going to highlight it. We're going to put it in a box. It's our useful equation for the day. Okay. So that's one platform, one way of doing it. What if you have two though? What if you have a seesaw? So just put that in a box. There we go. Well, we saw again in year 9. We looked at seesaws. So let's draw a seesaw. And in year 8, when we first introduced the idea of levers, one of my favourite things to do is have me, stood there, all 80 kilos of me, and pick the littlest person in the room. And there they are. Always go for the little one. And their job is to pick me up. Like that, with their derpy eyes. And what everybody realises quite quickly is that when it's like that, that's not going to work. Because my moment is going to be far larger than the little person's moment. So how can they engineer it? Eventually the whole class get the idea that you have to move the pivot closer to me. Now let's look at that in terms of Y for moments. Let's split it down here. Let's call this the this is the counterclockwise moment, and this is the clockwise moment. Okay, we've got here a distance from the pivot to the force, D, but here we've got a far greater distance. Come on, draw a straight line. There we go. So here we've got a much larger distance. This person has a small mass. This person has quite a large mass. Really got to stop eating. And so let's work it out. So on this side we would have M times little d, and it's got to be equal to little mass times big distance. So let's try it with a few numbers. Where would we have to put things? So let's say the mass of me, I said earlier, 80 kilos. And let's keep life easy. Let's say 1 meter. So my moment is not 80 kilos, be 800 newtons. There you go. Would be 800 Newton meters. Now, they would have to balance that, so they would need 800 Newton meters too. So let's imagine they are half my weight, 400 newtons. So 400 times 2 meters. They would have to stand a distance of 2 meters away to balance my 1 meter with me weighing twice as much. So that's called balancing moments. Balancing moments. Finally, moments can act in a different way. We can use circular motion, we can use gears. And if you've ever ridden your bike and looked at your gears, you've given it some thought about why does being in a different gear cause a different amount of force for when you pedal. You wouldn't really want to start off pedaling in the large gear, and when you're going as fast as you can, you wouldn't want to go to the small gear. So let's have a quick look at gearing and moments. If we take a large wheel and we take a small, well, we use the word cog. They have teeth. I'm not going to draw all of them. Okay, so we have teeth. And usually these ones will rotate slower, but they will have more force. Just like having a longer platform generates more force, more turning moment, so does having a larger cog. In this one, they have teeth as well. They will go faster. However, they will have a weaker force. And I can't fit it in. I didn't really plan that ahead. So normally you would start in the small gear so that you can pedal fast round and round. You would then, as you got faster and faster, move over to this one to keep the force going. Okay, so I'm using the old book, page 57. I haven't got a clue what it is in the new physics book. But what they say is different size gears can be used to change the moment of the force. The force transmitted to a larger gear will cause a bigger moment as the distance to the pivot is greater. Okay, so we'll write that down and that'll be the end for us. So we can write different sized gears can be used to change the moment of the force. A force, I'll write it underneath, a force transmitted to a larger gear will cause a bigger moment. Will cause a bigger moment as the distance run out of space. Let's just shrink this. Wish I could do this in real life. As the distance to the pivot is greater. Okay, if you're wondering what does that mean, it means if there's the gear, there's the pivot, imagine a column, a plank moving out like that. Obviously if the wheel, the cog, is bigger, then from the middle out to the end is going to be larger, the distance is going to be bigger, just like when we were looking at me with the one there. So obviously the smaller the wheel, the less the moment, the larger the wheel, the greater the moment. And that finishes this lesson. Thank you.